Okay, so we will start. We'll talk about the types of multimeter. This is all going to be a repetition. We did that a few times, but hopefully this time it will be consolidated and you have the knowledge on how to use a multimeter. What types of multimeters do we have? How do they function? How do we test? And again, as I said before, 80% of troubleshooting for all HVAC equipment is what? Electrical. So if you know how to test electrical equipment properly, you have saved yourself a lot of money and time. If you know if the problem is the motor, and you go and change the motor, and it turns out to be the motor, you're a hero. If it's just a fuse and you change the motor, you waste somebody's time and money. So knowing what is the faulty part is very, very important. That's why you get paid a lot of money doing that. And it becomes easier and easier as you have more practice. And this is going to be the first tool you use to know what's happening. And luckily for you guys, you are living in a really great age where a multimeter costs like $30 and has all these functions and is digital. 20 years ago, people used to have analog. Sometimes they broke, sometimes they get stuck, sometimes they calibrate. So now we have a lot of convenience. You have your phone which has a camera in it, has access to internet. So there's a lot of convenience. However, we have less critical thinking. Why? Because we are relying on it. So let's try to exercise our brain muscles and remember how these things are done. Okay. So I want to talk about how do we detect voltage, not measure, but detect. How do we detect voltage? Get the cards. Christian, how do we detect voltage?
We turned on our multimeter, we turn it to the voltage and we test it with our lead.
That could be, this is how you measure or detect voltage, but what if it's closed? What if you have no access? What do you use?
Oh, your voltmeter.
Yeah. So the voltmeter pen test for the voltage. How do we use it? You stick, does anybody have it around it?
Yeah.
Multimeter pen. It's important for two things: knowing if there's voltage or not, and also knowing which is hot and which is neutral. Let me see. Okay. So if you see there's a small little tongue on top of it, that's how you will know which side of the receptacle is hot and which is neutral. So if I stick this in the hot, make a noise, neutral, nothing. So hot and neutral. Everybody got that?
Yes.
Fantastic. Moving on. How to measure voltage? Now, measuring voltage, as Christian said, we take the leads, we put, so I had this question again yesterday, and I'm going to show you. And let's write it down. So this multimeter would not measure voltage if you put it on ohms, right?
No.
And actually it will show, it will tell you VDC and VAC. So please try to be mindful of what's actually it is showing before you put in your lead. If you put it on resistance and put it in the voltmeter, it's going to show you an error. And it's just a very silly mistake to do. So V is voltage, this is AC, this is DC. Write it down, please take notes. What if I want to measure the, what is this HZ here?
Hertz.
Hertz, what color is it?
Yellow.
So there's a yellow button here. So they make it very intuitive. You click the button and it should show you HZ, and if I stick it in, it will give me the hertz, 660. And you need that for HVAC appliances. Any question? Okay, this is how we measure voltage. Clear? You wrote it down? D symbol? Good. How do we measure amperage? Please do not use the leads to measure amperage.
Use the clip-on.
Yeah. I had at least 3 people trying to measure amperage using the voltage. No. You use a clip-on meter to measure amperage. Again, do not use the clip-on meter while the setting is in voltage. So I had that issue again, which is okay. We're here to learn. So, what are these? We said 2 amps, that's the limit, upper limit, 20 amps, 100 amp. So you can look at the equipment, or at least ballpark how much amperage you're gonna get. So something around 2 amps, it will say amps AC. If it's DC, you're gonna put amp DC, and you clip it on. And again, do not clip it on with 2 wires, clip it on in 1 wire. I'm gonna write this down. While the equipment on or off?
On.
Yeah. Okay. We're good? You write it down? So don't put it on amperage and clip it on and look at me. It's okay. Doesn't make sense. It's not gonna give you anything. You have to, because now it's gonna direct the whole reading to the lead. So put it on amperage. Okay? You got that. And notice also those color buttons. So this one is for blue. So if you want the blue option, you're gonna click on the blue button. This is to give you light, also hold, and the range again is 600 volts. Resistance. I'm going to write the same thing again. First of all, equipment on or off. It's one of the cases that you might zap yourself if the equipment is off and you put it on ohms. You're gonna go there, either the multimeter might not give you any reading, and if you have a very cheap one that's not protected, you might get a little bit with that. Equipment off, and multimeter. What did you call this thing?
Oh, we got a four symbol?
Okay. Maybe I'll help you. I don't know whatever that means. It's the omega.
Yeah, man.
Regular omega. O. And equipment on. And use leads. So I will use my leads. Which one of those? And it will show, it will tell you something here. It should show, I don't know if you can see or not, there's a lot of glare, but it says ohms, right? So if I want to measure the ohms for something, let's say this coil over here, I'm gonna go from here to here. Let's try this let's try this coil here. See this 2 lead for this coil? Gonna measure. And it should stabilize. If it goes up and down, probably you're not holding it right. So 30.2, and it should tell you either kilo ohm, mega ohm, or just ohm. This is how we measure resistance, and this symbol is for what?
Oh, the top one?
Yeah.
For,
Persistence?
no,
Continuity.
Continuity, when you get the noise. It's helpful when you're trying to see if things are continuous or not. Got it?
I always see it for Wi-Fi.
Actually, let's look at Wi-Fi, right. Capacitor. Okay. That is very important for you as an HVAC technician. Why? Again, where do we find capacitors? Where do you find these things, capacitors?
Near motors.
They're motors. A lot of motors require capacitors. It is conducive to smooth running and starting the motor. Some motor have more than one run capacitor and start capacitor. Okay, if you look at the side here, it shows you some kind of units. Let's get another one so you can see the units.
Those the ones that leak when they run old after the winter?
Yes. So that's a capacitor. It says 15 megafarad. So I will look in here and see, do I have a symbol for capacitor? So VA, over here. What is the symbol?
The circuit symbol is.
Micro.
Under the grid type of thing?
Microfarad.
Nitro with an N.
No, it's a small squiggly line.
It's mu.
Use leads. Equipment on and off. Off and discharged.
So you gotta like use a flathead to take it out.
Yep.
If it's on, it'll just explode, right?
No, it'll give you a lot of spark.
Huh?
Give you a lot of spark.
Fred. Fred? Yeah, Fred, F-A-R-E-D.
And if we have time, I'm going to show you how to discharge a capacitor just for fun.
Oh, yeah.
You can see the spark. And also we can use a resistance question.
What does that say up there? Right next to the school line?
Farad. So it's kind of like for hard with an arm.
I thought it was 5.
Well, we're related. Microfarad. Actually, it's Farad to Faraday, so. So okay, we got the discharge capacitor. So let's measure this one. So how do I get to this little line? You see, it's blue, right?
Yeah.
So I'm gonna click until I see the symbol for capacitor. This is for a diode. Now you see the F here
Yeah.
and nanofarad. So I'm in the right place. So I'm gonna go and check. I got 14.24 microfarad. So apparently they did not have the symbol for squiggly line, so they just put a big amper. It's not megafarad, it's microfarad. So I got almost the same within reason. And if you do refrigeration, they tell you for start capacitor and capacitor, you have a limit for plus 10%, minus 10% for running capacitor, plus or minus 5% for startup capacitor. Did you write this down? So we know how to test the capacitor?
Yes.
Okay. Danny? Good? Capacitor. Leads. Setting. We're good. Temperature. That's a tricky one. Not really. So some HVAC multimeters, which is this is actually called an HVAC multimeter. It has this symbol here. This looks like a thermometer, right? So I'm gonna go here, maybe it's thermometer. But for this application, I cannot use the leads. I'll change the leads, and I have to use what is called a thermocouple. So you can buy this leads and make sure it's the right polarity. This is the temperature of the room. Can I hold it? It's gonna increase temperature. So it's a good way to have temperature measure and to put that in. So how do you think this is measuring temperature? Remember when we talked about
Electricity,
no. Remember one of the means to generate electricity is heating similar metal? And we said that is thermal way to generate electricity. So this is generating small, this tip here. It's two metals, one of them is copper, one of them is nickel. At the tip, when it's heated, it's going to generate small amount of voltage. So just to show you, if you go to voltage, should be some voltage here. See, 0.01 is DC current. If I use, but they have, this has been calibrated to tell you what is the 0.001 corresponds to in temperature. If I put these leads, hopefully they fit, yeah they fit, and I go to voltage here, I should be getting something. Yeah, 0.4, 0.5 millivolt. So it's very, very small. And it's a very sensitive one. Okay, so with the temperature, we use thermocouples. We're good? Frequency, we did that. So we put it on hertz, stick it in the socket, and we'll measure frequency. Voltmeter pin, these are other kind of voltmeter pins. I don't know if you remember these, they were very popular in the 80s and 90s. It's a regular pin with ground on it. So you stick the pin in the receptacle and you hold the cap and it should light up. You have two lights, one for 220, one for 110. It was a very popular tool, probably still find them now.
I found one in my basement
They are there.
because there's my
So, from what we said yesterday, it's a magnetic field, and we are measuring the magnetic field and how far is it from the receptacle. Accuracy, some are more accurate than others. That's why a voltmeter pin varies from $7 to $60, based on the accuracy and the strength, how small of current it can detect, whether it can detect neutral or not, whether it can detect the 220 or 120, or 120 or 240. That's two. So again, just to distinct, have a distinction. Detection is not the same as measurement. So if you look at these, again, small multimeter, if you put it in the top here, there is a tool that will detect voltage. If you put it close, it should make a noise. So it does work. It says NCV. I don't know what is that short for. So we're talking about voltage. Voltage is always in parallel, meaning you have to put it with the circuit is on in parallel with the circuit. Pay attention to the range of voltage. All the multimeters we have now are auto-ranging. Some of the, you might buy one that's not auto-ranging. Just pay attention, make sure it's auto-ranging. What does that mean? that multimeter will cover the entire range from 0 to the maximum without you doing anything. And some of them, no, you have to put in the right range. Again, it utilizes Ohm's law. So whatever current goes through the leads is running through this resistance, and that's why we have to do some time ranging. So probably they have a big resistance in it, and whatever current goes through it, using the calculation to get the voltage. Leads and AC to DC, make sure it's set at the right setting. What happens if you put it in DC and if you set the multimeter on DC and you put it on AC current? What do you think will happen?
Cancel out.
It's just gonna
No.
say 0, right?
I'm reading it then.
What do you think?
What is it?
Feel- Yeah, it's gonna give you numbers back and forth, plus and minus, 60 times a second. So each will fluctuate depending on the meter, or sometimes you might get a 0, or sometimes it might give you an error. So make sure it's DC and AC. Jason,
So,
pay attention. Get a foolproof tool. What does that mean? Some, like these ones, they call it foolproof, which means if you put it in the wrong setting, it's not gonna blow, it's not gonna burn. I bought a cheap one for like $10, and as soon as you use the wrong setting, it will just burn. So this is a foolproof one. That's why it's a little bit expensive for brand new ones. If you put it in voltage, and you put it in resistance, then you put it in voltage, it's just gonna give you an error. It's not going to burn or get damaged. So they try to like anticipate for every possible way to do it. It's something in engineering called foolproofing, which means there's no way to put it the wrong way. They design it so it can be all installed the right way. They do that a lot with cars now, where they put so you don't have to, like they put a knob or something, you have to do the alignment, so you don't put it the wrong way or the opposite way. They used to put errors sometimes, that was confusing, so now they say, okay, we'll make it different size, we'll put a knob in it, we'll put a dent in it, so you cannot put it the wrong way, it has to be the right way. Okay. Amperage, we talked about amperage. Very small amperage, we're not gonna need to do that, but for a small amperage, you can connect the leads in series and measure the amperage. If you look at this here, if you look at this part, it says micro amp, AC or DC, for very, very small amperage. That's something that has to do with electronics. And at that way, you have to connect, you use the leads, and you connect it in series. We're not gonna use that in our applications, but at least you know it's there. Clip on, please do not clip it on 2 wires. I said that maybe now 63 times. I'm gonna keep saying it until the end of the semester, until you
And
get
it's
it.
only the one wire after basically the load.
Yeah. Or the neutral, doesn't matter. But I see people as anything, they go and just clip it on the plug and you get nothing. Resistance, the same thing, don't worry about that. Here it is. Pay attention to the symbols. Omega, ohms, continuity, ohms, capacitor, farads. A lot of technicians used to have this old device. This is just for capacity. But now you can do without with something different. Question?
Question, so when it has both, the God war symbol and, the continuity thing,
Yeah.
when it has the both, does it matter? Like, can you, like,
You put it, look where you set your dial.
yeah, cause in my thing, it has both of them.
Yeah,
and
but you have to toggle
so-
until you see the symbol here. It should tell you what is it reading.
Okay.
So check that. Resistance, again, we shut off the equipment, has to be off, and you put the leads at the beginning and the end of the resistance. And I showed you how that's done. For electronics, you do the same thing. Measuring capacitors, measuring small. Let's do that for it. capacitor, right? They try to measure. You see it? 2. What about this little capacitor here? Oh, what's one?
You gotta switch the leads around, or, oh,
It probably has to be
I
on.
seen that yesterday from
It's part of a
So it's
circuit?
on, it should not. I thought it did.
you know, I remember Bill saying something about flipping.
What about this fuse?
leads
If I wanna
around
test this fuse, what am I
to
gonna
a
do?
measured again.
Huh? Yeah, power? What about this little resistance here? Okay, this one. Which one's, what this one here? It's not activate, probably a switch. So, you get the idea, and these are all capacitors, these are relays. So it's somebody's job sometimes to go and trace a circuit and see if it works, if the component are burnt or not. How to measure frequency? We did that. You have to put in frequency. Temperature, I just showed you. You need to use the thermocouple. It's not that expensive. You can buy it from any hardware store. There's always new tools and new deals and local company. They can give you a package for like college back stuff. They can give you a clip-on. So it's always good to visit if you are interested in buying some of these tools. And it's very good to have your own tool so you know how it functions and you can expect what area of error does it have, how to calibrate it. That's why when you get a job, usually they issue you your own tools, so you take care of it, you know how it works, and you're responsible for the battery as well. Okay, any questions? Do you think you're comfortable working with a multimeter? Don't nod if you don't mean it.
I do.
Okay, thank you. We're good.
Alright.